Alright, this is a 1K thermistor, so I'm going to have to figure out how to scale it from my Arduino. I've got some ice and water in a bag, and a temperature thingy. See, this is pretty close to freezing probably. 38. So the resistance goes up as it gets cold. So about 2.1K, 2.2K at freezing. Then I'll warm it up to, my hands are kind of cold. .75. Goes down closer to 1K. So we wire up the thermistor like this, and the voltage divider, we've got 5 volts coming in, 10K resistor. Then we go through the thermistor, then a 10K resistor to ground, and then right in here we will go ahead and bring our signal into analog. So my voltage divider, I've got a 1K and a 2.2K, and of course this is a 1K thermistor. You don't have to get it perfect, you just need a decent range of motion. So if I get it up to about 80 degrees, about 275, and I get it down to about 40 degrees. .35 degrees to 33. So my range of motion is over, it's about half a volt, which is okay because in theory it could get colder or hotter than this. So we'll just scale it in the software. We'll call this voltage divider good and go ahead and scale it in the software. Alright, so we need to start a baseline so that we can scale this thing. So I'm just going to use my hand and a bag of ice. It's not the most accurate, but whatever. So my thumb seems to be consistently about 85 degrees. I have another thermometer just to double check my infrared one. And if we wait here, it usually goes right up to 85. So our top number we're going to scale with is 85. And our bag of ice is about 35 degrees. So I'm going to hold this, get it warm, and we're going to watch the program here. So here's the basic program. We are defining an analog input as A0. That we're calling it AI0, and we're attaching it to the first analog input in the Arduino. And then I'm making a variable that we can use to do our math. In the setup, we're starting up the serial print so that we can monitor our program. So we'll read the value and then we'll scale the value. I have this commented out because what you'll eventually end up doing is you're going to divide and then you're going to add or subtract an offset. So then down here we're going to print all these lines. I'm going to go ahead and upload this. Okay, so serial monitor. So we can see the raw value, scaled value. We don't care about the scaled right now. We're just going to look at the raw value. So I'm going to go ahead and hold this thermistor and go all the way up. Let it stabilize. Looks like 565 is about what I'm going to pick. So 565. And my bag of ice was 35. I'm going to hold that on there for a minute. Alright, so let's do 417. So we have these ranges here. So first thing I'm going to do is I'm going to find the difference between the two. So 85 minus 35. So we've gone 50. That's our main unit is 50. And then 565 minus 417. We went 148. So you can just do a cross multiply here, and we'll probably figure out how much we need to divide this number. So you cross multiply and then divide. So 1 times 148 divided by 50. I think we need to divide it by about 296. So that's our division, and then our offset, you can see that this number is way bigger. So at 35 degrees is where we'll start. Let's see, 417 minus 35. So let's subtract 382. We'll divide it by 2.9, and then we'll subtract 3.8 or 382 and see what happens. So where I messed up was I'm dividing it by 3, so this number should be divided by 3. So 129 should be my rough estimate of how much to subtract. What I finally come up with, I'm using the same division there. I'm subtracting 108, and my ambient temperature should be 73 in here, 73.9. I'm going to go ahead and squeeze this guy. And you know, body temp is what, 95, 97. So it's believable. If you want to control your, you know, what you're testing with a little better, you're gonna be able to tune it in a lot nicer. So, all right, and then my ice. You know, this ice is melting. It's not going to be 32. It's obviously going to be something higher than that. So let's get this down there. I think it might be around 40 right now. There we go, we're getting close. The little legs on the thermistor act as heat sinks. So right now they're actually cold because I had that ice on it. The top feels pretty warm, but they're cold, so they're still bringing cold up. So you have to let the temperature stabilize for a while. And also, you know, there are a lot of different kinds of thermistors. There's 100K thermistors. There's 1K, 10K, so, and they're all going to, the thermal curve is going to be a little different for each one. So you're going to have to experiment with it and scale it up to your particular thermistor and how you decided to build your voltage divider. And of course your source voltage changes it. This is a 5-volt Arduino. I have set these up with a 3-volt Arduino, and of course the scaling would be completely different. A good test would be to take it outside, let everything stabilize, be sure it's not in the sun, let everything stabilize, and then, you know, compare it to a thermometer. Also, you could track the temperature, so if you had this coming into some kind of software that could track the temperature, the minimum and maximum temperature for the night and day, that's where you could make a couple slight adjustments and get it within a degree probably.